Hi guys, welcome to Piece of Code and welcome to this video. So let's continue with the series, guys. Question number 26. A developer is integrating Amazon Elastic Cache in an application. The cache will store data from a database. The cached data must populate real-time dashboards. So which caching strategy will meet this requirement? So in the options we have a read-through cache, a write-behind cache, and a lazy loading cache, and a write-through cache, right? So basically you need real time. It means that it will just act like you are fetching from the database. It will be real time. Whatever it is written, you must get the latest data. So in that case, guys, the best thing will be a write through cache. So what happens the write through cache is, if this is a cache and this is the DB, right, and some new data is coming in, it will first write in the cache and then it will be write in the DB. So it will be written through the cache to the DB, right? And this will ensure that whatever data is being written into the database, you will get the latest data from the cache, right? That is the strategy that you want to use. Other caching strategies, if you see read through cache, so basically what will happen is the cache will not be updated every time. So if there is some change in the database which is not found in the cache, for example, you are trying to fetch some data, the client trying to fetch some data, if there is no data in the cache, then we will query the database, right, and then it will be written back to the cache. So the second time when we want to get the data, we will get it from the cache. But in that case, it will not have that real-time facility, so we'll not be able to maintain it. So obviously we will not go through the read-through cache, right? So basically a lazy loading cache is basically it will load the data on demand, so we don't want that. A write behind cache is nothing but it's kind of similar to write through cache, but it will be an asynchronous operation. It means that the data will be first written into the database and somewhere after that time it will be written into the cache, but when it will be written into the cache you have no idea. Basically the time is very less, so you can say that it is, it will be fast, but we don't know, right? We just want real time data, and that will not work with write behind cache as well. So I'm not going to go with that. So the correct answer is write through cache, right? Question number 27, guys. A developer is creating an AWS Lambda function, right? The Lambda function needs an external library to connect to a third-party solution. The external library is a collection of files with a total size of 100 MB. The developer needs to make the external library available to the Lambda execution environment and reduce the Lambda package space. Which solution will meet this requirement? The least operation overhead. I have told you like so many times, guys, if there are multiple Lambda functions L1, L2, L3 and they want to access a common library, you can create a Lambda layer. They can leverage that and use the common library. So we're gonna go with the Lambda layer, guys, which is A in this case. Alright, without any hesitation you have to go for that. Other options will not work, guys, because you can connect to an S3 bucket using Lambda, but there is a lot more things about mounting and then creating the roles and responsibility and all those things. It will be a pretty much a bigger overhead. Load the external library to the Lambda function /temp directory. Now this will tempt you. This is TMP and it will also tempt you. It's a lame joke, whatever. So you can store some this temporary data in the /temp directory of a Lambda function. That is true. You can also achieve this particular functionality doing that, but it is very complicated, guys, because you use that for temporary data, and if you want to update the package, then you have to update it in this directory, and as well all the /temp directories in multiple Lambda functions. So it's very complicated, so I'm not going to go with that. Doesn't make any sense. EFS is also going to the more overhead side, so I'm not going to go with EFS as well. A is the correct option in this case, guys. I hope you guys are following. Question number 28. Company has a front-end application that runs on 4 Amazon EC2 instances behind an elastic load balancer ELB in a production environment that is provisioned by AWS Elastic Beanstalk. A developer needs to deploy and test a new application code while updating the Elastic Beanstalk platform from the current version to a newer version of Node.js. Okay. The solution must result in 0 downtime for the application, right? Great. Which solution meets this requirements? So first option, let us read. It says clone the production environment to a different platform version, deploy the new application code and test it. swap the environment URLs upon verification. This might be the correct option. Let's put a dot over here and let's see other options. Deploy the new application code in all at once deployment. No way at all. All at once deployment just means that replacing the current production, you do an all at once deployment. If something is messier, then your complete production will fail. It will result in downtime, obviously. Not gonna go with that. Perform an immutable update to deploy the new application code on the new EC2 instances. Serve traffic to the new instances after they pass health checks. I would say that this is the correct option, guys. I would say that this is the correct option. Why? Because what is an immutable update is basically you have your EC2 instance, which is your primary production instances. You spun up 2 more instances, and what you do is, instead of redirecting the traffic to your old instances, these are the old pair of instances and this is a new pair of instances, you will redirect the traffic to the new pair of instances. Obviously after the health checks, you know, assure that those instances are up and running, and obviously you know, the requests do not fall through, right? Now if there is some issue with this new environment, you quickly switch back to your old instances. All right, it will be an active situation. You can create an active setup. Now all these setups and all I have discussed in my disaster recovery tab chapter. There is an active setup, there is an active passive setup, and a lot of other things. So in active setup, what will happen is that you will quickly switch back to your old instances, which kind of makes sense in this case. So I'm going to go with this C immutable update strategy. Now cloning the production environment to a different platform version, it's going to work. That's why I put a dot over there. But you know, then deploying your application code and test it, and then you have to swap the environment URLs upon verification. I don't think that it will be you know, a matter for me, you know, so I'm not going to go with that. A rolling deployment, obviously it's a very good you know, strategy. So you actually do not you know, roll out the feature or whatever you are working on in a single 100% deployment. You do it like 25%, 50%, 75%, and then 100%, but it will still result in some downtime. So I'm not going to go with that in this case. I'm going to stick with C. Alright, a developer is creating an AWS Lambda function, guys. Question number 129. Oh, sorry, not 129, 29. So a developer is creating an AWS Lambda function. The Lambda function will consume messages from an SQS, which is an Amazon Simple Queue service. The developer wants to integrate unit testing as part of the function's continuous integration and continuous delivery CI/CD pipelines. How the developer can test this function, right? So basically unit tests are nothing but you have developed a feature, and basically you want to test that particular piece of code. For example, this function fun, whatever code you're writing in this fun, it's executing as expected or not. You have your positive test cases and negative test cases, right? You will write all those test cases inside a class or something, whatever, you know, language you follow, you write JUnits or something like that, right? So let us see how do you achieve this thing. In this question, the feature is that consuming the messages from the Amazon SQS queue. That is very important to understand what is the feature that we want to test, right? So basically you have a function or a Lambda function. This function should be able to consume the messages from the SQS, consume from SQS. This is what we need. Okay, don't you know, make yourself think that it is some other things that needs to be tested. This is the thing that needs to be tested in this case. Now creating an AWS CloudFormation, doesn't even make any sense. It's a nonsensical option, because CloudFormation is used to, you know, it is used you know, infrastructure as a code, right? You want to like spun up EC2 instances, create a VPC and all, you know, automatically using piece of code. You will piece of code, you see my channel's name, whatever. So if you want to use code to actually create all this resources on AWS, you will use CloudFormation for that. But in this case, it's not the scenario, so I'm not going to go with A. Create an SQS event for what is that? For test, use a test that consumes messages from the SQS queue during the function's CI/CD process. Now SQS event for tests is not going to work, because you don't want to test on the same queue that you want for that you use for production, right? I'm not going to write tests on production things, right? I don't want to do that. I will have my separate queue for tests. So I'm not going to go with B because that doesn't make sense, because I don't want to test on the same queue and increase the load and then it will fail in production. I don't want that. But instead what I want to do is I will create an SQS queue for tests, use this SQS queue in the application's unit test and run the unit test during the CI/CD process, which absolutely makes sense. We'll create another SQS queue and we will check that, okay, first of all we will check in the test queue, we'll just push in some dummy messages and see that my function is reading those or consuming those messages or not. If it is consuming, then it is working fine, we can release it to production. Use AWS lambda invoke command with a test event during the CI/CD process. Doesn't even make any sense, because invoke command is used to manually invoke a lambda function, which we do not want in this case, right? It doesn't make any sense. Obviously you have to invoke the function, but invoking the function is not the test scenario in this case. Instead, consuming the messages from the queue is the test scenario in this case. So you have to be very much sure of what you are testing, right? Question number 30, it says developer is working on a web application that uses Amazon DynamoDB as this data store. The application has two DynamoDB tables, one table that is named artists and one table that is named songs, right? The artist table has an artist name as the partition key, the songs table has a song name as a partition key, and the artist name as a sort key. So keep in mind guys, it's a long question, so I'm just going to divide it into parts. So this artist table is the main table, just consider it as a main table, and it has the artist name as the partition key. Now there are a lot of keys, not a lot of keys, basically 2 keys in DynamoDB table. I'll try to make another video specific on DynamoDB guys, because a lot of people are asking for it. I'm going to discuss in depth about DynamoDB and what are RCU, what is WCU, and all the problems. There are some numerical problems also which comes on DynamoDB. So I'm going to make that video and it will be helpful for you guys. But for now, I am assuming that you have some idea on DynamoDB, because I'm not going to explain DynamoDB completely in this question. So we'll consider this as a main table. It has a partition key, and which is the artist name, and the songs table has 2 keys. One is song name as the partition key and artist name as a sort key, right? Which is fine. So the table usage patterns include the retrieval of multiple songs and artists in a single database operation from the web page, right? The developer needs a way to retrieve this information with minimal network traffic and optimal application performance. So minimal network traffic and optimal application performance, right? Those are the two optimization things that we should keep in mind. Now first option is perform a batch get item operation that returns item from the 2 tables. Use the list of song name artist name keys for the songs table and the list of artist name key for the artist table. Makes sense. Obviously, see, forget about the batch get item key operation. To retrieve the data from these 2 tables, you have to use the song name and artist name, because this is the partition key for the songs table and this is the sort key for the songs table. So you have to use these 2 things to fetch the data from the songs table. Now for fetching the data from the artist table, you have to select an artist, right? For example, Harry Styles or Arijit Singh, something like that. So you have to use the artist name, which is the partition key. So obviously you need to use this guy also as the partition key. That makes sense. Now how will you get multiple items from multiple tables? Using the batch get item operation. Okay, now batch get item operation, there is a common theory in mind of people that it will only get the data from a single table, but that is not the case. You can use batch get item operation to get multiple data from multiple tables. Okay, and that will be efficient, and also it will be, you don't have to make multiple calls throughout the network. That is also one of the optimization things that you can do. So that is A is the correct option in my opinion, right? So I'm gonna go with A in this case. Okay, now let us discuss about B. It says creating a local secondary index. Now it might work, but keep in mind that both of these 2 tables are created. You cannot create a local secondary index on an already created table. So that is not gonna work. So I'm not gonna go with B in this case. Perform a batch get item operation on the songs that uses the song name artist name keys. Okay, perform a batch get operation item. So why do you perform 2 batch get item operations when you can perform 1 batch get item operation and the work will be done? perform a scan operation. See guys, one thing that I'm going to focus a lot in DynamoDB is scan versus query, and query is more efficient than scan. The simple thing behind that logic is that scan will read all the item or each item in the database, but instead a query will only read based on your partition keys and your sort keys. So what do you think is more efficient, reading the entire table and then filtering from it, or reading what is required? Right, I hope that is making sense. So yeah, that's it about question number 30. Let's move on to the next question, guys. So let's see question number 31, guys. Okay, so one second. So company is developing an e-commerce application that uses Amazon API Gateway APIs. The application uses AWS Lambda as backend. The company needs to test the code in the dedicated monitored test environment before the company releases the code to the production environment. Which solution will meet this requirement? Now let's see through the options, guys. Use a single stage in API Gateway. Create a Lambda function for each environment. Now see, I'm gonna completely disagree with this answer, because I have already told you that in API Gateway, if you want to create multiple environments, for example test environment, UAT environment, or prod environment, you can create stages, right, in API Gateway. So why will you want to use a single stage in API Gateway when you want to test the code in a dedicated test environment? So not gonna make sense. So I'm gonna just ignore all the single stage options in this case. Now let's read through the multiple stages option, which is B and C. Multiple stages in API Gateway create a single Lambda function for all environments. Here, due to this line, I'm gonna ignore this answer, because you don't want to use a single Lambda function for all the environments. It will increase the load and also doesn't make any sense. You don't want to change the production environment Lambda function if you want to make some code changes directly, right? That is not the right approach. So without even reading it, I'm thinking that C is the correct option, because it says create multiple stages, create a Lambda function for each environment, and then you configure a stage variables to route traffic to the particular Lambda function of different environments. That makes sense. Yeah, that is correct. 32, guys, a developer creates an AWS Lambda function that retrieves and groups data from several public API endpoints. The Lambda function has been updated and configured to connect to the private subnet of a VPC. An internet gateway is attached to the VPC. The VPC uses the default network ACL and security group configurations. The developer finds that the Lambda function can no longer access the public API. The developer has ensured that the public API is accessible, but the Lambda function cannot connect to the API. How could the developer fix the connection issue? Now see, guys, if a Lambda function is there without any association with the VPC, it will by default have your public internet access. But when you create a VPC and put the Lambda function inside that VPC, it will lose all of its public functionalities, because by default when you create a VPC, it is private by default. Then you allow internet access by using internet gateways and NAT gateways and all that things. Now the thing is, if you remember, if you have seen my VPC lecture, I've told you that you need a NAT gateway if your device inside your VPC needs to connect to the outside internet, right? I hope that is making sense. So we have to check that the NAT gateway of this VPC is allowing outbound access to the internet, right? Then only whatever resource you have inside your VPC will be able to connect to the outside world or to the outside internet. Now I won't go with any other option, because that is the first thing that we need to determine, that our NAT gateway is working fine or not. That's why I'm gonna go with C option, which says that ensure that the outbound traffic from the private subnet is routed to the public NAT gateway, right? Okay, this thing is not working. Okay, pen is working now. Great. Now question number 33, guys, it says a developer needs to store configuration variables for an application. The developer needs to set an expiration date and time for configuration. The developer wants to receive notifications before the configuration expires. Which solution will meet these requirements with the least operational overhead? Now obviously you're going to use the AWS Systems Manager parameter store, because that is where we put our parameters, right? and here this expiration date or whatever things you have, these are also parameters you're going to store there. But if you see the options, option number A, create a standard parameter and AWS parameters store and set the expiration and expiration notification policies there. Now in the standard version of the AWS systems parameter store, you will not get this expiration and expiration notification facility, right? You will get it in the advanced parameter thing, which you have to pay some money for it. So I'm not going to go with the standard options over here. Now if you see the Bth option, it may seem a viable option, like for example create a standard parameter and then create an AWS Lambda function to expire the configuration and send SNS notifications. Now that may make some sense, but it is filled with a lot of complexities, right? I just want a straightforward solution. I don't want to do some magic on it, right? Like I don't want to over complicate it. Create an advanced parameter in AWS systems parameter store and set the expiration and expiration notification type policy types. Now this is going to work because advanced parameters have this functionality. So I'm going to go with the Cth option. Create an advanced parameter in systems parameter store, create an Amazon EC2 instance. Doesn't make any sense, right? If you have already created an advanced parameter, you will get that functionality to set the expiration date and everything. So not going to go with D as well. Okay, question number 34, guys. It says a company is developing a serverless application that consists of various AWS Lambda functions behind Amazon API gateway APIs. A developer needs to automate the deployment of the Lambda function code. The developer will deploy updated Lambda function code with code deploy. The deployment must minimize the exposure of potential errors to the end users. When the application is in production, the application cannot experience downtime outside the specified maintenance window. Which deployment configuration will meet these requirements? Okay, now let us see which will work in this case. Now use the AWS code deploy to in-place deployment configuration for the Lambda function. Now we discussed similar type of question, I think 2 or 3 questions back, right? So you guys should have a little bit of idea about the deployment strategies. Now if you use an in-place deployment, right, it is not going to work because you will shift all the traffic immediately to the in-place deployment. It just means that you just replace your current production with the new code, right? Doesn't make any sense. So it will result in some downtime. I'm not going to go with that. Linear deployment configuration. Now this is a good strategy. It's a more cautious approach, you would say, right? But you want some validation of your feature, right? It means that you want to shift some little percentage of traffic to your particular application, new version of your application, which will not work in a linear deployment configuration. So not going to go with that. All at once deployment, you are same as the in-place deployment, right? You don't want a sudden switch of traffic. You don't want to change your production all at once. You have to do it in some other way. So I'm not going to go with C. And the last thing that we are left with D. So by default it will be your answer. So this is a common elimination strategy which I have told again and again to answer questions in the exam. But let us read the option number D. It says use the AWS code deploy predefined canary deployment configuration to shift 10% of the traffic immediately and shift the remaining traffic after 5 minutes. Now what is a canary deployment configuration or strategy? Is that it will allow you to release a new version of your application, and then what will happen is it will allow you to shift a percentage of traffic to your particular application. For example, you send your traffic in an increment of 10%, first 10%, then 20%, then 30%, 40%, likewise, and similarly go till 100%, right? It's a phase wise release strategy, okay? And that is what we need in this case. And code deploy has that predefined canary deployment configuration, and first of all you shift 10% of the traffic immediately for that validation that you need, right, that my feature is working or not, and then after that you shift the remaining traffic after 5 minutes. Okay, let's go to question number 35. It says a company created 4 AWS Lambda functions that connect to the relational database server that runs on Amazon RDS instance. A security team requires the company to automatically change the database password every 30 days which solution will meet the requirements most securely. Now guys, time and time I've told you, whenever you have something with the database and you want to store secrets of the database, which is username and password. Pardon my handwriting, it's very bad, but whatever. You will go with the secrets manager. So without even blinking, I'm gonna go with the B8th option, which says AWS secrets manager, right? I hope that is making sense. I'm just gonna not even look at other options. So that is it. Alright guys, so let's move on to the next. Okay, so let us see question number 36. Okay, and what does it say? It says a developer is setting up a deployment pipeline. The pipeline includes an AWS code build stage that requires access to a database to run the integrations tests. Okay, the developer is using a build spec.yml file to configure the database connection. Company policy requires automatic rotation of database credentials. Guys, we have done a lot of questions based on this database credentials thing, rotating credentials and everything, and every time the answer has been AWS secrets manager. Whenever there's something related to database and you want to rotate the credentials and everything, your answer should always move towards AWS secrets manager. So I'm going to go with option number C, which says retrieve the credentials from an environment variable that is linked to AWS secrets manager secret, and then configure secrets manager for automatic rotation. I'm not going to look at any other options because we have done this type of questions like numerous times, right? So yeah, let's move on to the next question, guys. Question number 37. It says a company is developing a serverless multi-tier application in AWS. The company will build the serverless logic tier by using Amazon API gateway and AWS Lambda, right? While the company builds the logic tier, right, a developer who works on the front end of the application must develop integration tests, right? I mean, obviously we have a front end and a back end. The back end has not been already developed, but they want to test the front end, right? And the test must cover both positive and negative scenarios depending on the success and error and the HTTP status codes. Yeah, which solution will meet these requirements with the least effort, right? So see guys, we know a lot of things we can do with API gateway, right? We can set up stages, write rules, write codes, whatever you want you can do with an API gateway, what kind of response it may return. But in this case it's a little bit different. In this case we want our API gateway to behave in a way such that the front end will think that the actual business logic is being sent from the API gateway, right? What we can do in this case is we can mock the behavior of the backend. Now if you are not using for example API gateway or something, if you want to go by your own, this is just normal developer knowledge that I'm given, it is not related to this AWS and all. So if you don't want to go in the way of AWS or using any kind of a service, you want to do it on your own, you can create a mock server which will return certain responses which the front end wants, and you can write your tests in the front end. But in this case we are not gonna work with the mock server because we don't want that. Instead we have to search for a solution that is in these options, right? So one other way we can do this is that we can create a mock integration for API methods in the API gateway. Now what are these things? They are nothing but you'll write some simple logic, right, as it is shown in this question. You will add some simple logic to return either a success or an error message based on the HTTPS status code. This is kind of like a mock server only, and this feature is available in the API gateway. So obviously A is the correct option in this case. And why? I gave you a lot of reasons in this case, because the backend is not ready and you want to test your front end. So I think this should be your answer that you should be looking for. If you talk about other options, guys, create 2 mock integration. You don't want 2 mock integrations in this case, one will do just fine. Create Lambda function to perform tests. See, in this case you are writing the logic itself in the lambda function. That will be your backend, right? In this case, why, if you don't want to do that, if you don't want to go in that path where you want to write the actual business logic, you want to mock it, it doesn't make sense to go with the lambda functions approach, right? Just let's just leave it. And similarly D also I'm not going to consider at all, right? I hope guys this explanation is enough for this question. Let's move on to the next question, question number 38. It says users are reporting errors in an application. The application consists of several microservices that are deployed in an ECS with AWS Fargate. Okay, so which combination of steps should a developer take to fix the errors, guys? Let's read through the options, guys, and let's see. Deploy AWS X-Ray as a sidecar container to the microservices. Update the task role policy to allow access to the X-Ray API. Now, yes, this may work. So let's put a dot in this question, because you can deploy AWS X-Ray as a sidecar container, right, to the microservices. You can do that, because the thing is, you know, if you want to directly install the X-Ray daemon, you have to work with an EC2, right? EC2, it will instrument it and then it will send the logs, right? So, but this is not the case of an EC2 image or a EC2 based application. This is a microservice based application, right? So yeah, the only way I think that can be done is using a sidecar. So let's read through the other options, guys. Deploy AWS X-Ray as a daemon set to the Fargate cluster. Daemon set is not going to work. It is not, daemon sets are usually used to run in backgrounds, right? And basically this whatever this collecting of the logs thing and instrumenting thing is not going to work with a daemon set, guys. For more information on daemon sets and all, you can learn about this Kubernetes concepts, guys. We have the concept of stateful sets, daemon sets, and a lot of other things, right? What is a deployment object, what are services and everything. You can have some idea on that if you go through the Kubernetes you know, thing. You can just search it up on the internet, you will get some idea on that. Okay, C says instrument the application by using X-Ray SDK. Update the application to use put X-Ray trace API call to communicate with the X-Ray API. This may work, so I'm also going to put a dot beside it. Instrument the application by using X-Ray SDK. Update the application to communicate with the X-Ray daemon. This is just straightforward thing. It is not telling us a way in which how you're going to use your X-Ray SDK, so I'm not going to go with that. Instrument the ECS task to send the std out and stdr output to Amazon CloudWatch logs. Update the task role policy to allow CloudWatch pull logs action. Now this is one of the correct options, guys, because see, if you want to debug something, you have to get the logs first of all. So even if you don't understand all the options in this question, E should be one of the options, because you have to send the logs anyhow. The only confusion in this case is between A and C, what you want to like do it, right? And in my opinion, guys, I would go with C, right? Because in ECS, right, in Amazon ECS, if you are, you know, with Fargate, if you are doing, you can create a Docker image that runs the X-Ray daemon, right, and you upload it to a Docker repository like Amazon ECR or Docker Hub or anything, and then you can deploy it to your Amazon ECS cluster, right? So in this case, we can instrument the application by using X-Ray SDK. We don't have to deploy it as a sidecar. Now if you guys have some other thoughts on this question, you can very well put it down in the comments. I will have a look. But in my opinion, guys, and I think it is correct, that C and E are the correct options. And I'm not saying that A is not a viable option, it is also a viable option, but in this case, going with C will be little bit more, I would say, you know, less overhead. Right, so C and E, in my opinion, are the correct options, guys. Let's move on to the next question, question number 39, guys. And it says a developer is creating an application for a company. The application needs to read the file doc.txt that is placed in the root folder of an S3 bucket that is named doc example bucket. The company's security team requires the principle of least privilege to be applied to the application's IAM policy, right? Great. And which IAM policy statement will meet these security requirements, guys? So just we have to see that which policy actually gives the access just to that doc.txt file and not to any other things in your S3 bucket, right? And in my opinion, guys, A is the correct option in this case. If you see, because if you see the policy of A, it makes sense, right? The effect is allow. You are only giving access to the get object API of the S3. You don't want to give write access also, put object or something like that. You're just giving get object over here, and the resource is particularly the doc.txt, guys. Okay. Now coming to B, you are giving everything in S3. You're giving allow everything to all of your buckets and everything. Just doesn't make any sense. Not going to go with that. C says get object effect allow, and even though this is giving just the bucket access, still you are giving the access to all other files in the same bucket, which I don't think is a good solution. And similarly, you are not going to give other permissions other than the get object to your document. So yeah, that's why A is the correct option, guys. Let's move on to the next question, question number 40. Okay, so question number 40 says that a company has an application that uses AWS code pipeline to automate its continuous integration and continuous delivery workflow. The application uses AWS code commit for version control. Developer who was working on one of the tasks did not pull the most recent changes from the main branch. A week later, the developer noticed some merge conflicts, guys. Now, if you are a developer, this is not specific to just this CI/CD pipeline or just to AWS. In fact, you would be facing this like a lot, right, if you are developing something. So yeah, you should be knowing this if you are a developer. So if you see clone the repository, create a new branch, update the branch with the changes, doesn't make any sense. It is a lot of overhead, guys. I don't want to do that. As a developer, I will not going to do that. Create a new branch. Why would you create a new branch? Use the commit visualizer view to compare the commits from the feature that was added. Fix the merge conflicts. I mean, you can do this, but I'm not going to go with this. Stop the pull from the main branch to the feature branch. Rebase the feature branch from the main branch. So this is the correct option, guys, because see, you have your main branch or your master branch, and you have your feature branch, right? So what will you do if there is some inconsistency between the branches? You will rebase your feature branch on top of your main branch. So rebasing is nothing but replacing your feature branch updates with your main branch updates, right? You can do that. Then what would you do is, on top of the rebase, you will apply your features or your changes. After this rebasing and applying your features, or whatever code you want to write, that is applying of the features, after this is done, you merge it with the main branch. This is generally the cycle that we follow while doing this thing, right? While releasing a new feature, or if there is some merge conflict or something like that, right? I hope that is making sense, guys. So let's move on to the next question. So let us see question number 41, guys, and it says a developer wants to add request validation to a production environment, Amazon API Gateway API. The developer needs to test the changes before the API is deployed to the production environment. For the test, the developer will send test requests to the API through a testing tool. Which solution will meet these requirements with the least operational overhead? So they are adding some new code to the business logic. It seems they are adding a new validation to the production environment, and what can be done in this case with the least operational overhead. So let us see the options, guys. It says export the existing API to an open API file, create a new API. Just by reading this thing, I'm not going to go with this, because you don't need to create a new API. That will just be additional overhead in this case, guys. Modify the existing API to add request validation. Deploy the updated API to a new API gateway stage. Now this is the key point in this case. Perform the test. Deploy the updated API to the API gateway production stage. This is the very correct answer, guys. Very least operational overhead. What you are doing is just modifying your existing API, and then you are deploying it in a new stage, for example a test stage, right, and you test all your scenarios and then you actually deploy to the production, which makes sense. Creating a new API is never, I'm not going to consider this. Clone the existing API is just similar to creating a new API, guys. Not going to go with that. Now question number 42, guys. Okay, it says an online food company provides an Amazon API gateway HTTP API to receive orders for partners. The API is integrated with AWS Lambda function. The Lambda function stores the order in an Amazon DynamoDB table, right? The company expects to onboard additional partners. Some of the partners require additional Lambda functions to receive orders. The company has created an Amazon S3 bucket, right? The company needs to store all orders and updates in the S3 bucket for future analysis. How can the developer ensure that all orders and updates are stored in S3 with the least development effort? Now guys, the thing is, what is the important thing in this question is that to store all orders and updates in the S3 bucket for future analysis. Basically, whenever there is a insert / update in the DynamoDB table, right, you have to store that action. Maybe you have to log it for audit purposes, something like that, right? Who knows? If you remember, if you have studied about DynamoDB, guys, you would think you would remember that there is a concept of DynamoDB streams. This is nothing but DynamoDB streams are used to record any action that happened on your DynamoDB table, like an insert or a delete or an update, right? And you can use that action to trigger a Lambda function, for example, which will in fact take the data and store it in the S3 bucket. So I already gave you the answer. So in my opinion, C is the correct option, which says enable the DynamoDB streams on the DynamoDB table and create a new Lambda function which will do your job. Now if you talk about other options, now this was a straightforward question, so I gave you the answer. But if you see the other options in this case, creating a new Lambda functions and a new API gateway endpoint, it's not gonna make any sense. Kinesis data streams to create a new data stream. Now it may work, but you have to create a new data stream and you have to, configure it and do a lot of work, which is a lot of additional overhead. Modify the Lambda function to publish a new SNS topic. Doesn't even make any sense. It's just stupid. Not gonna go with that. Question number 43, guys, and it says that a company's website runs on Amazon EC2 instance and uses auto scaling to scale the environment during peak times. Website users across the world are experiencing high latency due to static content on the EC2 instance even during non-peak hours, guys. See, the problem is here is that the websites across the world are experiencing high latency even during non-peak hours. So auto scaling is not the problem in this case. Auto scaling will be the problem if your whatever application is not responding during peak hours, because during peak hours your auto scaling should scale up your needs, right? So in this case, guys, I'm not gonna consider any auto scaling answers, right? I'm not gonna go with this A option or scale vertically or something like that. So A and C are out of the option completely. Hosting the application code on AWS Lambda doesn't make any sense because it is already on EC2 instance. Why will you remigrate it to a serverless architecture? If serverless architecture is required, then you may go, but other logic wise and scaling wise doesn't make any sense. So I'm not going to go with AWS Lambda. And D, create an Amazon CloudFront distribution to cache the static content. This is one of the correct options, because what is Amazon CloudFront used for? It is basically used to, you have your edge locations throughout the world, right? And you want to cache static content on the edge locations. And whenever there is a user who wants the data, you just check your edge location, like if the cache is present, right, if the data is present, you fetch it from your edge location, otherwise you go to your source. So this will work in this case. CloudFront is a very viable option in this case, and if you want to have a good knowledge on CloudFront, you can watch my CloudFront video which is up on my channel. You can also go there and have a look. Store the application static content in S3. It makes sense because S3 provides you like the most efficient way to host static content and also static websites, so you can use that feature in this case. Okay, makes sense guys. Let's move on to the next question, question number 44, and it says that a company has an Amazon S3 bucket containing premier content that it intends to make available to only paid subscribers of the website. The S3 bucket currently has default permissions of all objects being private to prevent inadvertent exposure of premier content to non-paying website visitors. How can the company limit the ability to download a premier content file in S3 bucket and to paid subscribers only? It's a pretty straightforward question guys, and I would say this is a baby question, right? Why? Because you're going to use a pre-signed URL. So whenever there is a S3 based question which says there are external users who don't have access, who are not AWS users, who don't have access to your bucket or your object, and you want to, they are paying or have some subscription based service and they want temporary access to a file or something on your S3 bucket, you would always go with a pre-signed URL guys. And in this case I'm going to go with a pre-signed URL. I'm not going to even consider other options because we have done this kind of question a lot of times in the solutions architect series also, and now in the developer associate series. Okay, let's move on to the next question guys, question number 45. Now this question is a little bit bigger question, but I think this should have a very simplest answer guys, because most probably I've seen that a lot of bigger questions have the simplest answers, right? So here it says a developer is creating an AWS Lambda function that searches for items from an DynamoDB table that contains customer contact information. The DynamoDB table items have the customer's email address as the partition key and additional properties such as customer type, name and job title, right? The Lambda function runs whenever a user types a new character into the customer type input text. The developer wants to search to return partial matches of all the email address property of the particular customer type. The developer does not want to recreate the DynamoDB table. Now there are certain options in this case guys. Now if you see the options in this case guys, I will not go with any LSI, which is local this index, right, local secondary index, because once your DynamoDB table is created, you cannot create a local secondary index again, right? So I'm not going to consider any local secondary index options. Now this is a very faster way to eliminate the options, because if you have learned about DynamoDB, you will know that LSI you have to create while creating your DynamoDB table, but in the case of GSI, which is a global secondary index, you can create it at any time. Now between A and B, what you have to choose in this case? So let's see the 8th option, which says add a global secondary index to the DynamoDB table with a customer type as the partition key and email address as the sort key. Perform a query operation on the GSI by using the begins with key condition expression with the email address property. Now this makes sense. Why? Because first of all, you created a GSI with customer type as the partition key and email address as the sort key. That will work. GSI would work in this case. Now if you have to do a partial match based on the email ID. So as our user starts to input the this email ID, you have to search for that email ID. For example, that's a scenario. You can use this begins with key condition expression. It allows the developer to perform a partial match on the email address property for a particular customer type, because begins with will get matched. For example, if your email ID is wiki@gmail.com, while you are typing wiki, it will check for the emails which starts with the word wiki. Now talking about the bth option, guys, add a global secondary index GSI to the DynamoDB table with email address as the partition key and customer type as the sort key, because you don't want to go with the email address as the partition key, guys, because it doesn't make sense. You have to do partial matches on the email address itself, not the customer type. So I'm not gonna go with B in this case. A is the correct option. It's pretty straightforward question, guys. Always the biggest ones fall the least or whatever. Yeah, let's move on to the next question. Question number 46, guys. See question number 46, and it says that a developer is building an application that uses AWS API gateway, APIs, AWS Lambda functions, and AWS DynamoDB tables. The developer uses the AWS serverless application model SAM to build and run serverless applications on AWS. Each time the developer pushes changes for only to the Lambda function, all the artifacts in the application are rebuilt. The developer wants to implement SAM accelerate by running a command that only redeploy the Lambda functions that have changed. Which command will meet this requirements? Okay, now let's read through this this commands, guys, and this SAM topic is becoming a very, I would say, what we call popular topic nowadays, right? And if you see through these options, I would say that the correct option in this case is SAM sync -- watch. Now what happens with this command is that this SAM sync command, what happens is that it is used to sync the local artifacts with the S3 bucket, and it uploads local artifacts to S3 and creates or updates the stack. This watch attribute that you have, it watches for any changes that you are making, right? And only those changes are synced with your S3, for example, right? You don't want to push all the artifacts to S3, right? That is what it is asking in the question. You just want selective artifacts to be pushed, and this watch will help you to do that. Other options, guys, if you see the force upload, it will upload all artifacts. Not going to go with that. Not execute change set is not going to work. And also SAM package is used to package your application. It has nothing to do with updating your local artifacts. I hope that is making sense, guys. Let's move on to the next question. Question number 47. It says a developer is building an application that gives users the ability to view bank accounts from multiple sources in a single dashboard. The developer has automated the process to retrieve API credentials for these resources. For these sources. The process invokes an AWS Lambda function and is associated with an AWS CloudFormation custom resource. The developer wants a solution that will store the API credentials with minimal operational overhead, and also they want to do it in a secure way. So obviously going to use secrets manager nonetheless, right? But which option of the secrets manager, systems manager or secrets manager, right? Yeah, you're going to use. Now first is add an AWS secrets manager, generate string resource in the CloudFormation template, set the value to the reference new credentials for the CloudFormation resource. Now the generate secret string will generate a very good I would say secured string, but it will be a random string, right? It's not gonna store your API credentials that you want, so I'm not gonna go with A in this case. B says use the AWS SDK SSM put parameter operation in the Lambda function from the existing custom resource to store the credential as a parameter, set the parameter value to reference the new credentials, set the parameter type to secure string. I think this is the correct option, because when you use the SSM put parameter operation, it is used to create or update a parameter first of all, and you can use it to store your API credentials securely, right? And if you use the parameter type as secure string, the parameter values are encrypted with a KMS key, and that is the secure thing that is asking in the question, that will be covered in that. Talking about option number C, add an systems manager parameter store resource to the CloudFormation template, set the CloudFormation resource value to refer the new credentials, set the resource no echo attribute to me. In this case it will not work, guys. Now D says use the AWS SDK SSM put parameter operation in the lambda function, and it goes on to say the same things that is asked in B. The only difference in this option is that set the parameter value to the reference, the new credentials, that is fine. Set the parameter no echo attribute to true. Now this no echo, what does it do is that if you mark it as no echo, it prevents the parameter value from being displayed in the console or the CLI, right? Now the actual value is not encrypted in this case, right? But just that the value is not visible. And if you ask my humble opinion in this case, if a value is not visible but it is not encrypted, it is still very much of a security threat. You want to encrypt. Now anybody can see the string, but they should not be able to decrypt the string. That is more important than not being able to see the string. You see what I'm getting? People get confused in this case and they go with this no echo attribute because they think that, you know what, this is not visible, so I think it is probably secure, right? But that's not the case. So I'm not going to go with D in this case, guys. I'm going to stick with B. Okay. Now question number 48, guys, and it says that a developer is trying to get data from an Amazon DynamoDB table called Daemon table, whatever. The developer configured the AWS CLI to see a specific IAM user's credentials and ran the following command: AWS DynamoDB get item, some command like to fetch some item, and the command returned errors and rows were not returned. It's a very relaxing question, guys. That's a very straightforward answer, guys. Okay, so when the it is trying to use the IAM user to run this command, it is not being able to fetch the data. Instead it is being returned with some errors. Now the command is correct, not gonna go with the command is incorrect. Developer needs to log a ticket to AWS support. Support will not do anything if your command is not working. You have to resolve it yourself. DynamoDB cannot be accessed from the AWS CLI. That is one of the biggest lies that I have heard from this option. The only answer left is D, which is the correct option. So the IAM user needs an associated policy with the read access to the daemon table. Obviously, if the policy is not there, the permission is not there, how the user will be able to access the table, right? Makes sense? Great. Question number 49, guys, and it says that an organization is using Amazon CloudFront to ensure that its users experience low latency access to its web application. The organization has identified a need to encrypt all traffic between users and CloudFront and the traffic between CloudFront and the web application. How can the requirements be met? Now, if you read through the option, use AWS KMS to encrypt the traffic between CloudFront and web application, doesn't make sense because KMS is basically, in this case, in the scenario is used for server-side encryption maximum times, or if you want to rotate some customer managed keys or something like that, you can use KMS for that. Second option says that set the origin policy, protocol policy to HTTPS only. Now this will work because if you set it as HTTPS only, then the requests which are HTTPS only will only get through, otherwise non-HTTPS requests will not get through. Set the origins HTTP port to 443, doesn't make any sense. Even though the HTTPS port is 443, you have to enable the HTTPS only for this to work. Set the viewer protocol policy to HTTPS only and redirect HTTP to HTTPS. That's what I'm saying. Not a cross, this is the correct option. So I'm going to go with a tick. So any request that has to be HTTPS only, that's what you need to do. Enable the CloudFront option, restrict viewer access, doesn't make any sense because it is asking you to encrypt the traffic between the users and the CloudFront. It means encryption in transit, and that is happening only due to HTTPS, right? I hope that is making sense. Question number 50, it says that a developer is planning to migrate on-premises company data to S3. The data must be encrypted, the encryption keys, and must support automatic annual rotation. The company must use AWS Key Management Service to encrypt the data. and what will be the answer in this case, and which type of keys should the developer use to meet these requirements. Now I would suggest that you use customer managed keys for this particular thing, because okay, you know what, I'm not gonna go with B actually. If you read through the options, at the first glance I thought, you know what, I would use customer managed keys with a key material that is generated by AWS, because I thought of this rotation thing, right, annual rotation. But if you have a look, you can directly use S3 managed keys, right, and it supports annual rotation. Obviously you will not be able to manually rotate it, right, but that is not given in the question. It is not asking you for you to manually rotate it. It is just asking for annual rotation, which happens in S3 managed keys itself. You don't have to create the key, you don't have to manage the key, anything else. So it is providing you this feature with the least operational overhead, and it also satisfy your question or your feature. So I'm going to go with S3 managed keys. Other options I'm not going to go, because since I selected B as the correct options in the start, obviously it is going to work, but due to the operational overhead concept, I'm not going to go with that. Same thing with C, and D also I'm not going to go with that. So I'm going to stick with the very simplest answer, which is Amazon S3 managed keys. If you have something else on your mind, you're free to comment it down and I will be checking that. Okay guys, so let's move on to the next question in the next part of this video, which is coming soon. So stay tuned guys.